Hey, this video is going to be over the triangle congruence postulates and theorems. It's going to be a pretty short video. There's not going to be a whole lot of math and examples in this video. It's just going to be kind of going over these postulates. These postulates are very important. They're going to be used for the rest of this unit up through Christmas break. So it's important to know these, all right? The first one is SSS. So these postulates, all right, are abbreviated, okay? S stands for side and A stands for angle. So this is the side, side, side congruence postulate. So it says if all three sides of one triangle are congruent to all three sides of another triangle, then the triangles are congruent. Okay. Actually. So what this kind of looks like, all right, if you have two triangles and they have side lengths that are all the same, then those triangles are going to be congruent. Okay, and this is called side, 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 or SSS. So let's get a big old one right there. All right. Okay. And basically these are going to be used for proofs. These are going to be like the last steps of your proofs in order to prove triangles are congruent. So we've proven that three sides are the same. Therefore, the triangles are congruent. So there's a bunch of these. These are what you guys were supposed to learn during the triangle in a bag. Now, I know we didn't have that much time to go over that because we kind of had to rush it right before Thanksgiving break. But yeah, so the second one is SAS. So that stands for side angle side. So this is if two sides and their included angle. So that part is important, all right? We'll talk about that in a minute. Of one triangle are congruent to two sides and their included angle of another triangle, then the triangles are congruent. So what this does not mean, all right, this doesn't just mean any two sides in an angle, okay? It has to be, all right, it has to be the angle that is in between the two sides. All right, so for example, if we have 7, 10, and this is 40 degrees, okay, that works because it's the angle that's in between those two sides. All right. If it's like a different angle, like if it was that angle up there, that would not work. So this is called side angle side, or we are going to abbreviate it as SAS. So you don't need to know the names. Well, actually, you do need to know the names, but we'll write it as SAS in our proofs. Okay. The next one is ASA. So it's kind of the same. This is angle side angle. So it's if two angles and their included side. So this time the side has to be in between the two angles. All right. So just like the angle had to be in between the two sides, the side has to be in between the two angles. All right. So again, this will look kind of like this. Now, it doesn't have to be oriented the same way, all right? Can I spin this around? Yeah. So let's say that it was upside down, right? Like that. Pretend like they're the same size. Okay. And I knew that this was 35 degrees, and I knew that this was 25 degrees, and I knew that this was 8. All right. It can be congruent to this triangle, all right? If we had, so we would have 25 degrees up here, and 35 degrees, and then 8. So this would be an example of angle, side, angle. We've got angle, side, angle. So you can kind of say it out loud as you count what you know. Angle, side, angle. Okay? So that's ASA. So that's our third one. So we've actually got 5 that you need to know. All right? So you need to make sure that you know all 5. All right? The next one is actually AAS. So for this one, you still have 2 angles and a side, but the side's not in between the 2 angles. So you actually don't need the side to be in between the 2 angles. If you just have 2 angles and a side at all, then you're going to be using one of these two. So I have 2 angles and a non, a non, not an English teacher, and a non-included side of one triangle are congruent to 2 angles and a non-included side of another triangle. All right, then those 2 triangles are congruent. All right, so again, oh, that's a right triangle. Don't want that. It could be a right triangle. All right, so how would this one look? All right, so again, let's say that's 50 degrees. Say this is 45 degrees. So if you have 2 angles, and it could be either of these 2 sides, all right, we could say this is 9, all right? Should have copied it first. But again, it doesn't have to be oriented the same. It could be turned, but we've still got a 45, a 50, and then we've got that 9 over there in the same spot across from the 50. And it's not in between the 2 sides, so that's what makes this AAS. So that'd be angle, side. So what doesn't work? All right, which combination of angles and sides won't work? The one that will not work, so we've got SSS, SAS, ASA, AAS. The one that will not work is side angle. All right, side angle actually won't work. Because you can, if you have 2 sides and an angle, there's actually multiple triangles that you can get from that. So I'm going to try and draw side, This one's kind of hard to draw. Angle, let's see. So let's say that's, let's see close to, let's say that's our angle right there, okay? So that's 40 degrees. So if I've got both of these situations, okay, where we've got a side length and we've got an angle, there's actually two different spots Wait, I made this side too long down here. Actually, I just need to make this, so I'm sorry guys. I need to make this side longer. There's actually two different spots where this side can hit, all right? So we can draw that triangle up there. So I need to copy this, oh my gosh. I need to copy this side. This is the first time that I'm doing this, so I'm trying to make it good. And then I'm going to copy this side and show you that everything is the same. All right, except I can make a different triangle. Oh, no, don't get bigger. I just want it to turn. Basically, I don't know, can I keep this one still and then turn that? No, I can't. All right, well, I'm going to show you. You can go like that. All right, so there's actually two spots where it can hit. So this could be like 10, 8, 40. This could be 10, 8, 40. And it actually makes a different triangle. All right, so that's why basically you can't do SA. So you can't do SSA, and you also can't do ASS either, but I'm not writing that out in this video. So SSA will not work. If you try and use it, you're going to be wrong. Last one is HL. So this one's a little bit different. All right. HL actually stands for hypotenuse leg. So think about what is hypotenuse. So if the hypotenuse and one leg of one right triangle, so this only works with right triangles, all right, are congruent to the hypotenuse and one leg of another, of another right triangle, then the triangles are congruent. So what this looks like basically is this is a special case of SSA that actually does work. And it's only if you have a right triangle and the angle that you're using is the right angle. So these two triangles are actually congruent, okay, under hypotenuse leg. So it's like side, angle, right? But it still works, but only in this one circumstance. So this is the only circumstance where SSA actually works, but we don't even call it SSA, we call it hypotenuse leg. So those are the 5 theorems. All we're doing in the next 2 days is just practicing using the theorems. We're not actually going to start doing proofs yet, okay? But this is what the theorems are. So we really need to be able to recognize when these theorems apply to triangles. So you've got to practice today. Go ahead and try that practice. If you have any questions, let me know, and have a great day.